Hey everyone, we're going to look at number 14 in section 3.10. We're given a 5-meter ladder that leans against a wall. Assume the bottom slides away from the wall at a rate of 0.7 meters per second. Okay, they give you a little diagram, and I don't show you that one, but I showed one of the diagrams here. Find the velocity of the top of the ladder at t equal 2 seconds if the bottom is 1.5 meter from the wall at time t equals 0. Okay. Give your answer to 3 decimal places. So whether or not they give you a diagram, you should draw a diagram. I've drawn a simple one. Here's the house or wall rather. Here's the ground. Here's the ladder. So we're going to assume this is a 90-degree angle. We're not going to have, any. This is perfectly flat. No ups and downs. Don't complicate things. And the bottom of the ladder slides away. So here's the bottom of the ladder, right? It's sliding away from the wall at a rate of 0.7 meters per second. So at the same time, the top of the ladder is going to move down the wall, right? So we're going to neglect frictions. Think of either end of the ladder being on roller, wheels. Not a very good ladder, but this is going to come down, and this top part is going to stay connected to the wall until it hits the ground, right? So again, we're making assumptions to make the problem doable, if you will. Okay, so how do we set this up? So first of all, what information are we given? We're told that the ladder is sliding away at 0.7 meters per second from the wall. And so notice that's the rate of change of x. And notice x is getting bigger as time progresses. And so we have dx dt, the rate of change of x with respect to time, is 0.7 meters per second. What are we asked to find? Find the velocity of the top of the ladder. Well, the top of the ladder is moving down, and notice as it moves down, I've called h the height here. H is getting smaller. It's changing. It's the rate of change of h with respect to time. So we're finding dh dt. Of course, we're going to find it at t equal 2 seconds. Okay, so what's the variable, what equation rather relates our variables of interest, x and h? Well, we've got a right triangle here, and we can see Pythagorean theorem comes into play, right? And that is x squared plus h squared is 5 squared. 5 squared, of course, is 25, right? So we get this relationship at any point in time, x squared plus h squared must be equal to 25, right? The length of the ladder is fixed. It's not changing. Don't assign a variable to that, right? That is fixed. It's not an extendable ladder, right? In this case. All right, so now calculus, we take this equation, we take the derivative with respect to time of both sides. Now, on this side, let's just do that. That's easy. What's the derivative with respect to time of 25? 25 is a constant. It's 0, right? In other words, there's no rate of change. The length of the ladder is not changing. However, when we take the derivative of x squared, we've got to use a chain rule, right? X is a function of time. X is this length from the wall to the bottom of the ladder. That X length is changing. It's a function of time. And so the inner function is X, the outer function is X squared. Chain rule says take the derivative of the outer function, derivative of X squared is 2X, times the derivative of the inner function, remember with respect to T, so it's dx dt, the rate of change of X with respect to time. And similarly, the derivative of H squared is going to be 2H dH dt. So here's my related rates equation. This is very important. This is what relates our variables of interest. And so we're looking for dH dt. So I'm just going to solve this equation for dH dt. I'm first going to divide both sides of my equation by 2, right? And I get this. And then I'm going to subtract x dx dt for both sides. And then I'm going to divide by h. Excuse me. Okay, so now I need to plug in. I need to know what dx dt is. Well, I know what dx dt is. That's 0.7 meters per second. And then I need to know what x and h are. Well, what are x and h at the instant that time is 2 seconds? Well, let's see. We're told some information here. We haven't talked about this a whole bunch, but we're going to find the velocity at the top of the ladder at t equal 2 seconds if the bottom is 1.5 meters from the wall at time 0 seconds. So at time 0, the bottom of the ladder, which is x, or the distance the bottom of the ladder is from the wall, which is x, is 1.5 meter. That's what we're told. So at 2 seconds, what's the distance going to be? Well, it's going to be that 1.5 meters, but also remember it's moving away at 0.7 meters per second. And so for 2 seconds, it's going to what? 2 times 0.7 or 1.4 meters, right? It's going to have traveled. So 1.5 plus 1.44 is 1.4 is 2.9 meters. So that's the value of x at time 2 seconds. Well, I also need to know what h is. I know what x is. I need to know what h is. Well, what's h at that same instance? Well, notice from the Pythagorean theorem, we know x squared plus h squared is 25. So if I solve for h by subtracting x squared and taking the square root, there is the equation. And since x is 2.9, h is just this expression, square root of 25 minus 2.9 squared. So I'm going to replace this is, don't forget this negative sign. That's going to be important here. We'll talk about that in a minute. It's negative x is 2.9. H, as we said, is this expression times dx dt, which is 0.7. Okay. So putting this in your calculator and then rounding it off to 3 decimal places gives us negative 0.498. I'll just show you that real quick in my calculator. The way I would do that is negative 2.9. I would go and multiply times 0.7, and then I would divide it by the square root of 25 minus 2.9 squared. All right, so that would do it. I don't have to put parentheses around the square root because the square root has essentially parentheses around the inside of it. And so there you see what we get. Now, of course, the units are meters per second, right? Because that's the rate of change of the height of the ladder, and the original rate of change for the bottom of the ladder giving in terms of meters per second. But why is it negative? Why would it be negative? Does that make sense? Well, yeah, it does, because the value of h is getting smaller, right? It's decreasing, and therefore our derivative is negative. Okay, so that makes sense. So always when you're doing these problems, make sure your answer makes sense. Should your rate of change be positive or negative? Make sure that is consistent with the problem statement. Okay, I hope this helps to understand this interesting ladder problem.